Welcome back. This is the third and last lesson recording for week 6 of distance learning IM2. Where we left was we finished an example and we ended up with 144 inches squared as our answer. Now this is your turn to try it. So here are the problems. Please consider these questions, answering these questions. Where are the bases? How many faces? Are any faces the same size? Is there enough info to find all the areas? Please pause the video and try this now. Okay, what do you have? So again, please write your answers, show your work in a systematic way so that you do not lose anything. You don't forget to add a panel or side or anything like that. Okay, so you have two top and bottom surfaces and then two side panels. I'm going to call this side panel 1, side panel 2, and then the front and back. So you have 6 different surfaces, and the top and bottom is going to be 2 by 1, and we have 2 of those, and the side panel is going to be 2 by 2, so and we also have 2 of those, and then the front and back panel is going to be 2 by 1, and you also have 2 of those, and add it all up, you get 16 feet squared. For this triangular prism, okay, you have 2 triangle bases, the top and bottom, and then you have the right panel, the left panel, and then the front panel. Okay, try to visualize as much as possible. Okay, so then you have, okay, for the 2 triangle bases, the area is going to be, this length is same as 9 meters, so it's going to be 9 times 6 times half, but we have 2 of those, so we multiply that by 2. For the right panel, it's going to be 9 times 5. We only have 1 of those. Okay, do not make that mistake. And then left panel is 7 by 5. And finally, the front panel is 8 by 5. And you add that all up, and you should have gotten 174 meters squared. Okay. Alright, here are the challenge problems. I would like you to try to do this now. Please pause the video and I'll come back with the answers. Okay, I hope you had a chance to try it. Here we go. The surface area is going to be two triangles, and then the back side and the bottom side and the front panel. So the 2 triangles, to calculate the 2 triangles, we need to find the height of the triangles. Okay? And we can find the height of the triangle by using the Pythagorean theorem. We have the hypotenuse, we know the base, that's 3, so we can figure out the height, and so the height has to be 4. Then from here, we can draw some color coding that might help us, and then figure out each panel area. So the 2 triangles are going to be 3 times 4 times half, then double it because we have 2 triangles. That's why you have we've gotten rid of 2 times half because they cancel out to 1. So, and then you have the back is going to be 8 by 4. We just figure out this length to be 4, and the bottom is 3 by 8, and then 5 by 8. Add them all up and you get 108 kilometers squared. And then for this problem, how do we figure it out? The surface area is going to be 2 pentagon plus 6 rectangular face. Actually, this should be 5 rectangular face, my error. Okay, so how do I figure out the area of the pentagon? Well, I can create these 2 little triangles. We have 5 of those triangles, and so it's going to be 5 times half times base. Base we know to be 6 yards, and the height of the triangle is 4.1, and we have 5 of this triangle, and then you have 2 of those panels, the bases. And then to that we have 5 of these rectangles, which is made up by 4 is the height by 6. So that comes out to 240 43 yards squared. Okay, all right, then let's look at surface area of cylinder and cone. To invest surface area of a cylinder, the formula is given by 2 pi r squared plus 2 pi r h, where r is the radius of the cylinder and h is the height of the cylinder. Now, how do we get there? Look at this cylinder, and then it gets opened up, and it is formed by a rectangle and then the two circles, the top and the bottom. And the area of two circles is pi r squared, and the height of that rectangle is just height of the cylinder. But what about this length? Notice what happens. It just, how long this is from just the outside surface, outside circumference of this can. Okay, so if you cut it in half, where it opens up, this length matches up exactly as 2 pi r, which is the circumference of the circle. So that's how you get that. So let's have a look. Oops. Okay, so now that we know the formula, we can plug in the values. Okay, now you can just plug in the r value, radius, and the h, the height, into the equation and solve from there. We know that 6 squared is 36. We know 6 times 10 is 60. And I know that I can multiply 36 times 2, so to get 72 pi plus 120 pi, which leaves us with 192 pi. And now we are back to exact answer. Okay. Alright, so now let's try this problem now. I want you to pause the video and see if you can solve the surface area of this problem. Okay, what do you have now? The radius is 1, height is 3, and so the surface area is going to be 2 times pi times 1 squared times 2 times pi times 1 times 3. The height is 3. Remember, it's 2 pi r h. 2 pi r h. That should be easy to remember. That's the circumference times height. Circumference times height. And that simplifies to 8 pi centimeter squared. And then this problem, r is 9 because diameter is 18 yards. So, and the height is 5. So surface area is 2 pi r squared, that's 9 squared, plus 2 pi r times 5, which is the height, which simplifies to 252 pi yards squared. Great. What about finding the surface area of a cone? Okay, the formula is given as pi r squared plus pi rs. Now let's consider how we got that equation. The surface r is the radius and s again is the slant height. Just like the pyramid, we now are back to slant height, not just regular height, but slant height. So to understand this, you are going to go to this cone, tinyurl.com, IM2 cone net, and from there you will do some exploration. Please come back when you're done. And so surface area of a cone is this equation. How do we get that? You have a circle, and it's really the surface area. The top part is really a sector of the larger circle, and that larger circle, this part corresponds to the circumference of the smaller base, and this is the height of the slant height. Okay, so sector area is a fraction of the circle area with a radius. So the fraction, how much of the circle, whole circle, do we have of this blue circle? The fraction is really just the arc length divided by the whole circumference, right? So what is the arc length? Well, how much arc do we have? Well, this happens to exactly match up with the circumference. So we can change that as orange circumference over blue circumference. Do we know the formula for orange circumference? Yes, it's 2 pi r with a little radius. Okay. What about the blue circumference? Well, the blue circumference is 2 pi r, except the r in this case is slant height, s. So now from here, it's just a little bit of algebra. The sector area, this blue shaded area, is just going to be the fraction of the circle you have multiplied by the whole blue circle area. So the fraction we have is just this, 2 pi r over 2 pi s times pi s squared, because the blue circle has the radius of s now. And this simplifies to r over s when you cancel out 2 pi's at the top and 2 pi's at the bottom, and that pi s squared can be written as pi times s times s, which this s and this s cancels each other out, and you're left with r pi s, and pi rs is what we have. And that's how we got the pi rs. And this is this orange circle, and pi rs is this blue shaded area. Okay, so now that we understand how we got the formula, we can just plug in the values that we have, and then you get s is the 13 inches, that's the slant height, and so r is 5, s is 13, plug that in, and you get 25 pi plus 65 pi, and you get 90 pi inches square as your surface area. Okay, I want you to try this yourself, and I'll show you the answers in a minute. Here we go. Alright, r is 4, s is 8.9, and so plug it in. I want you to get in the habit of drawing the net for this cylinder, just so that you are familiar with how you got there. So the radius, the little radius is 4, but the slant height is 8.9, and so it's going to be pi 4 squared plus pi r pi times 4 times 8.9. Okay, let's look at the next problem. Okay, this time we're given the diameter, so we need to figure out the radius to be 7, and so slant height is 15.7, and then from there plug it in, draw your net so that you do not get the slant height and the radius confused, and you plug that in and you should have gotten 158.9 pi feet squared. Okay, that's it for today, and we'll see you next time.